Suppose you draw two cards from a deck. What is the probability that both cards are aces? Can you simply add the probabilities? No. Whenever you see the word "and", you're dealing with the multiplication rule. Today you'll learn independent events, sampling with replacement, sampling without replacement, and how to recognize which rule to use. What is the multiplication rule? The multiplication rule is used to find the probability that both events occur, that is, event A and event B happen together. The key word is "and". And the formula is probability of A and B, that is the probability of A intersection B, would be equal to the probability of event A occurring times the probability of event B occurring. And that is for independent events. So you'll simply multiply their individual probabilities together to find the probability that both occur. Two events are independent if the outcome of one does not affect the probability of the other. For example, flipping a coin twice, rolling two dice, or drawing a card, replacing it, then drawing again. For example, if you have two dice and you want to find the probability of getting a 6 on the first die and a 4 on the second die, these two events are independent. So we can simply multiply the probability of both events occurring. So probability of getting a 6 would be 1 over 6, and the probability of getting a 4 is 1 over 6 as well. When we multiply the two, that will be equal to 1 over 36. Let's now discuss sampling with replacement. When an item is selected and put back before the next selection, the probabilities stay the same. Because nothing changes, the events remain independent. For example, a bag contains 5 purple and 3 blue marbles, so 8 in total. One marble is drawn, replaced, that means put back into the bag, and then another is drawn. We want to find the probability of getting 2 purple marbles. So to begin with, when we first draw a marble, there are 8 marbles in total and 5 of them are purple. So the probability of getting a purple marble is 5 over 8. Now since the marble is put back into the bag, on the second selection, there is still 8 marbles in total in the bag and 5 of them are still purple. So the probability of getting a purple marble the second time is 5 over 8 as well. So 5 over 8 times 5 over 8 is 25 over 64, which is the probability of selecting 2 purple marbles. Now, when the selected item is not replaced, this is what we call sampling without replacement. In this case, the probabilities change after the first selection, making the events dependent. For instance, if we want to find the probability of getting 2 aces from a deck of cards, and we're sampling without replacement, the probability that the first card is an ace from a 52 card deck will be 4 over 52. Now, when we're drawing the second card, only 3 aces remain and 51 cards remain. So the probability that the second card is an ace as well will be 3 over 51. Now, when we multiply the two probabilities, 4 over 52 times 3 over 51, that simplifies to 1 over 221. And that would be the probability of selecting 2 aces from a deck of 52 cards. Why did the probability change, you may ask? Because the first card was not replaced, the first draw changed the deck. Fewer cards remain and fewer aces remain. So the second probability is different from the first. This is what makes the events dependent. So remember, with replacement, that means you put it back. Nothing changes, the events are independent. But without replacement, you don't put it back. So everything changes, the events are dependent. Here's your challenge for today. A jar contains 6 green marbles and 4 yellow marbles. 2 marbles are drawn without replacement. What is the probability that both are green? Try it yourself before reading the solution. In this case, in the beginning there are 10 marbles, 6 of which are green. So the probability of getting a green marble at first will be 6 over 10. Since it is not replaced, the probability of getting a green marble the second time will be 5 over 9 because only 9 marbles remain and 5 of them are green. So if we multiply 6 over 10 times 5 over 9, that will be equal to 30 over 90, which simplifies to 1/3. Here's the fast track test. Before solving any probability problem, ask yourself those 2 questions. Do I see and or? If it's or, use the addition rule. If it's and, use the multiplication rule. If it's and, the question is, was the item replaced? If yes, the events are independent, the probabilities stay the same. But if no, the events are dependent and the probabilities change. These 2 questions will help you choose the correct probability rule almost every time. Thanks for watching. Please like, subscribe, and share. And don't forget, math success starts when you stay on the fast track.